Hey guys, welcome to EduKaji. If you guys are first time here, allow me to introduce myself. So my name is Walter and I'm a chemistry tutor as well as a real life scientist. So this particular video will be discussing about a past trial paper for the SPM Chemistry syllabus. So without further ado, let's jump right into it. Okay, right. So this is the Perak state trial paper for year 2022, and this is the set one for paper 2. So let's take a look at the questions together. So we'll go on with the section A first. So number 1 here says 1A, table 1 shows the number of protons and neutrons for the atom of elements Q and X. The letters used are not the actual symbols of the elements. And you can see over here, Q has 11 protons and 12 neutrons. X has 17 protons and 18 neutrons in total. So what is the nucleon number of atom Q? So when we talk about the nucleon number, is referring to the total number of neutrons and protons. So you just add these two numbers together. You should be able to get 23 as your answer. Okay, I ask you to write the electron arrangement of atom Q. How do we get the electron arrangement? You must first know the number of electrons. So in a neutral atom, the number of electrons is actually the same as the number of protons. Okay, so if this particular element Q has 11 protons, then it must also have a total of 11 electrons as well. So the electron arrangement of atom Q will be 2, 8, 1. Okay, 2, 8, 1. That's the answer. So you get 1 mark for that. And number 3 it says draw the electron arrangement of ion Q. So ion Q means after it releases out its electrons, because they're referring to ion, not atom. If it's ion Q, then we're talking about the Q has already formed an ion after releasing electrons. So since it got only 1 valence electron, so it should technically release only 1 electrons out to form a positively charged ion. So to do that is very simple. You just draw 3 circles. Right. And then inside here you put Q, and then you can use either a cross or dot as your electrons. So I'm going to use dot over here. So you should have a maximum of number of valence electron, because after that it has already achieved octet, which is a total of 8 outermost electrons. Then you just draw a bracket around it. Okay, and then you just put here plus. Then you should be able to get 1 mark for the question already. Let's go to B. B, atom Z has an isotope, it's actually an isotope of atom X. So Z is an isotope of X. So state the number of protons in atom Z. So atom Z is the same as X. So isotopes are technically the same element, okay? So if it's the same element, means they must have the same number of protons as well. So I would say here the number of protons for atom Z will be 17. So why atoms Z and X have the same chemical properties? So usually they have the same chemical properties. You know, being isotopes, they're still the same element and they have the same number of electrons. So your answer can be very simple. You just say that they have the same number of electrons, or even if you want to be more specific, you can just mention the word valence electrons. So therefore, I can just put here X and Z. Has the same number of valence electrons. There you go. You get 1 mark for that. So if you score everything perfectly, you should be able to get 5 marks for this particular question. All right, number 2. Diagram 2.1 shows an equipment made of a kind of alloy. State the meaning of alloy. So alloy is actually a mixture, okay, of 2 or more elements, which the main element must be a metal. So you put here a mixture of elements, or you can just put there 2 or more elements. 2 or more elements in which the main element must be a metal. You're gonna get 1 mark from there. And then number 2, name the alloy for the equipment in diagram 2.1. So I'll say that this is supposed to be a key that's made of brass usually. So you can just put here brass. Yeah, so keys are normally made from brass lah. So it's more chemically resistant towards corrosion and it won't break so easily, right? State 2 elements that produce the alloy in your answer in A2. So it's asking you what are the main constituents of brass, and the answer is copper and zinc. So you get 1 mark from there. Let's take a look at B. Diagram 2.2 shows a white clay used to make white pottery, which is called kaolin. And how do you want to produce a green colored pottery? So usually if you want to make a pottery or a, I would say a ceramic material that is made up of colors. So sometimes you see the pots and also those, what's it called, the flower vase and everything else that, you know, you put plants. They can be in different colors, right? So if you want to make those I would say those kind of pottery in different colors, you can actually use transition elements to make them the colors, because we know the ions of transition elements or compounds of transition elements can give them certain color. So in this case here, it must be something that can give you a green color. So I would say the best and the easiest to remember will be iron 2, because iron 2 ions are actually green. So in this case here, we can just use a compound of iron 2 lah. So you can choose things like iron 2 oxide or iron 2 chloride. Any iron 2 based compound should be able to give you a green color. Okay, so so it's 2 marks question, right? So you must actually explain why iron 2 oxide can be used. So you can just actually explain and say that iron 2 oxide can be mixed together with kaolin. To make green pottery. And you have to explain why as well. So you can just say that because iron 2 oxide contains iron 2 ion. Okay, you just put that Fe2 plus, which is green. So if you were to answer all correctly, you should be able to get 2 marks. And total for this question is actually 5 marks. Okay. So look at number 3. Table 3 shows the information of the elements in the periodic table. So we have these elements arranged across period 3. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and they didn't put in the argon, but it's okay. So they give you the arrangement of electrons as well as the atomic radius. So which period are the elements placed in? So like I said, they are technically period 3. How can we tell? By looking at the electron arrangement. So you can see the electron arrangement shows you that they have 3 electron shells. All of the elements listed here got 3 electron shells. So the number of electron shells corresponds to the period that they're in. So therefore, the answer here will be 3 for A. For B, state the element that exists as a diatomic molecule. So we'll state that diatomic molecule here will be very simple. Most of the time, group 17 elements, which is the one over here, group 17 is chlorine. They exist as diatomic molecules lah. So like chlorine, fluorine, bromine, iodine, they're all diatomic molecules. So you can put here chlorine. So that gives you 1 mark as well. Sodium burns in oxygen, okay, to form sodium oxide. Write the chemical equation for the reaction. So this is also very simple. It's basically just Na plus O2. You get Na2O. But to balance the equation, you put 2 over here and 4 over here, and you'll be able to get 2 marks in total. Okay. All right, D, referring to the change in the atomic radius, explain why the electronegativity increases across the period from left to right. So it's referring to electronegativity. If we don't know what electronegativity means, it is the tendency of a particular element to accept electrons. Okay, so again, electronegativity is actually referring to the tendency of a particular element or an atom to accept electrons. So in this case over here, I will say that the reason why going from left to right across the period, the electronegativity increases is because they already give you the atomic radius, you see, and apparently the atomic radius decreases from left to right. So that causes the attractive forces from the nucleus towards the electrons on the outside much more stronger. Okay, so therefore, it's easier to accept electrons. So the first answer they must put inside will be very simple. You can just say that electronegativity increases across the period because the atomic size of each element decreases gradually. Or the atomic radius also can. Okay, so that's the first part. And after I explained that the attractive forces between the nucleus and the electrons increases. So that actually sort of like allows the nucleus or the particular atom to attract electrons much more easily into its valence shell compared to the others. So that should give you 2 marks for 2 explanations. So if you answer everything correctly in this question, you should be able to score 6 marks in total. Let's go to question number 4. 4.1 shows 3 diagrams of electron arrangements of compounds E, F, and G. All right, they are all molecules. So state the type of compound for compound E. So compound E is, if you see closely, it's referring to ammonia, and ammonia is made up of non-metals sharing electrons together. So therefore, it must be a covalent compound. So just put here covalent compound. Okay, and then for B, compound F and compound G can react with compound E respectively. State the name of the new bond formed between E and F. So let's take a look at E and F. So E and F can combine together to form an ionic compound, supposedly. Why? Because this is supposed to be hydrogen chloride. So when ammonia reacts with hydrogen chloride, you actually get a new substance called ammonium chloride. So in this case here, if E and F is being formed, then the new bond will be ionic in nature. Okay, so you can just put there ionic bonding. So that's because you see here NH3 plus HCl, you actually get NH4Cl. And if you were to see NH4Cl, it consists of NH4 plus and also Cl minus. So when they are attracted to each other, they actually form this ionic bonding, like, because they both become ions technically, right? So that's the answer. And then between E and G, I would say that when ammonia dissolved in water, it can also produce what we call as the ammonia solution, or aqueous ammonia. And inside the aqueous ammonia, if you notice, what happens is that the ammonia will form a hydrogen bond with the water, supposedly. So that's the reason why, is because the hydrogen can actually be attracted to the oxygen from water, therefore forming this hydrogen bond. So that's why you can actually form hydrogen bonding inside. So therefore you can put here hydrogen bonding. So you get 2 marks over there. Very simple. C, diagram 4.2 shows the formation of metallic bond of aluminum. Okay, so there is the aluminum ion on the inside. And then the blue color ones actually represents electrons. Okay. So explain how the formation of metal bonds of aluminum occurs. So I think it's very simple. You can say that the atom of aluminum releases 3 electrons each. Or yeah, I think can. So you put here aluminum atoms release 3 electrons each. All right, so that's the idea. And after that, you say that the aluminum atom becomes an aluminum ion. Then you say that the aluminum ions are surrounded by you can choose to write a sea of mobile electrons, or you can, yeah, I think it's a sea of mobile electrons is actually a better choice of phrase of word. So you can say that the aluminum ions are surrounded by a sea of delocalized electron. Then you say that metallic bond is formed when the Al3 plus ions are attracted to the delocalized electrons. So that the electrostatic force between the aluminum ions and also the electrons will create this pulling effect towards each other. That's why they're actually attracted to each other. So the ions cannot possibly attract to each other because they have the same charge, right? Aluminum is positively charged, so if they were to come close to each other, they should repel each other. But because there is a presence of delocalized electrons between the ions, so the metallic bond is formed when the aluminum ion is actually attracted to the electrons outside. and then it pulls them close to each other. So that's how metallic bond is formed. So if you answer that correctly, you should get 4 marks for that, and the whole question will give you a total of 7 marks in total. Okay. Let's move on to the question number 5. 5.1 shows an apparatus set up to prepare an insoluble salt between copper 2 chloride and sodium carbonate solution. So according to this, what you're going to get is actually an insoluble salt of copper carbonate. All right. And this process is called double decomposition. So that is the idea. So state the meaning of salt. So I think salt is very simple. You can just put there an ionic compound formed, okay, when a hydrogen ion of an acid is replaced or displaced, okay, is replaced with a metal ion. So that is the idea behind it. You can say also metal ion or ammonium ion because ammonium is not metal. So you can also put the ammonium ion. That should be correct. That's the definition of a salt. And you can just memorize this because if this comes out, the answer should be the same. Number 2, write the chemical equation for the reaction. So now we have sodium carbonate, which has a formula of Na2CO3. And you also got a solution of copper chloride, which is CuCl2. So what you'll get after that is technically copper carbonate plus 2NaCl. There you get 1 mark for that. Make sure to balance chemical equation. Third one, calculate the mass of the precipitate formed. So according to this question, now you have the, what they have is 25 cm cube of 0.5 mole per dm cube of sodium carbonate. And another one, which is 25 cm cube of 0.5 mole per dm cube of copper to chloride solution. So you can see in this question, they're all 1-to-1 ratio. So if they have the same molarity and also the same volume, they should have enough. There's no excess, there's just enough for it to react completely. So what we can do over here is to calculate the number of mole of the copper chloride that's being formed. So all 1-to-1 ratio. Sorry, this is supposed to be 2 moles, but it doesn't matter. We're focusing on copper carbonate. So all 1-to-1 ratio. So we can take any of the values over here to calculate the number of mole of the solution. So what we can do now is to calculate number of mole of any substance of Na2CO3 or CuCl2, and you can just use the formula of mv over 1000. So that should be 25 and 0.5, isn't it? So you can put here 0.5 times 25 divided by 1000. Then you should be able to get a total of 0.0125 mole. Okay, so just have to compare the moles, the ratio. So number of mole of CuCO3 form will also be 0.0125 mole, right? Because it's a 1-to-1 ratio. And then the next part is to calculate the MR of copper carbonate. So that will be 64 plus 12 plus 3 times 16. See how much that is. So you get 124. All right. So now to get the mass of precipitate. will be equivalent to 0.0125 mole multiplied by 124. So you should be able to get 1.55 grams of precipitate form. So calculate everything correctly, you should be able to get 3 marks in total for this question. Okay, so use the formula of MV over 1000 to get the number of mole and then compare the ratio, that's it. The experiment was repeated by replacing sodium carbonate solution with solution P. It was found that the insoluble salt form are the same, identify solution P. So it must be the same type of solution which can dissolve, as in like a metal carbonate that can dissolve first. So you can choose any other two. Only all salts of sodium, potassium, and ammonium are soluble. So your replacement for this will be either potassium carbonate, or you can also use ammonium carbonate, okay, because these are the two of the soluble ones. So choose any one of those, you can get correct 1 mark. And then for B, diagram 5.2 shows the apparatus used in experiment to study the action on carbonate salt. So we have number 1 over here, magnesium carbonate is heated, then there's a lime water there. Lime water does turn cloudy. And then second one, sodium carbonate, heated, lime water, no change. So carbon dioxide gas is produced for experiment number 1, but experiment number 2 would no carbon dioxide being produced. I explain the difference in experiment 1 and experiment 2. So you can just put there, magnesium carbonate decomposes to release carbon dioxide. That's will give you 1 mark. And after that, you can see that sodium carbonate does not decompose. Upon heating to produce carbon dioxide gas. So as long as you write that one correctly, you should be able to get 2 marks. So if you get all correct for this question, you should be able to get 8 marks in total. So number 6, diagram 6.1 shows a shell. So this is a seashell probably from the seaside. Shells are made from a type of salt, and it's normally in the form of calcium carbonate. Okay. So A, Salma crushed the shells into small pieces, and then she put pieces of shells into a test tube, and then 50 cm cube of 1 mole per dm cube of hydrochloric acid is added. Gas T is released. Still the name of the gas T. So if you want the chemical equation, I think we'll write this down first. Calcium carbonate actually decompose upon, calcium carbonate will react with hydrochloric acid to produce a salt, which is calcium chloride. And it will also release our carbon dioxide gas, and it produces water. Okay, so that's the idea. So the gas that's being released is supposed to be carbon dioxide. So you can just put here carbon dioxide. Okay, Munira uses hydrated oxalic acid crystals to prepare 250 cm cube of an acidic standard solution, as shown in diagram 6.2. All right, so what happens here is that she adds distilled water to the salt dissolves, then she puts inside the volumetric flask, and then she top up with water until it reaches the graduation mark. So then you can see that they actually explain to you. So what is meant by a standard solution? So a standard solution is a solution with a known concentration. Okay, so you can put here a standard solution. We're going to just put there a solution that has a known concentration. Okay. Number two, calculate the mass of hydrated oxalic acid crystals that needed to be dissolved in 500 cm³ distilled water to produce the standard solution with a concentration of 1.5 mole per dm³. Okay, so what we need to do now is calculate the mass to get number of moles. So what we need to do right now is very simple. First step is to get number of mole of the oxalic acid crystals. So number of mole will be MV over 1000. So right now it will be 1.5 times 500 cm³ divided by 1000. So this will be 0.75, okay? So 0.75 mole of oxalic acid crystals will be needed, but we don't want that in moles, right? What we want is actually in mass. So we calculate the mass. So the mass itself, we must first determine what is the MR of that particular substance. So the MR of bracket COOH 2.2H2O will be so a total of 94. So right now, your number of mole already, right? And also the relative molecular mass. What we can do is now to get the mass. So mass of bracket COOH2 dot 2H2O will be 0.75 multiplied by 94. They get 70.5. Then double check my calculation and see whether it is correct or not. So it looks too little. Let me double check again. So we got 24 plus. Oh, okay, wait, I calculated wrongly, sorry. So 12 times 2. And then 4 times 16. I missed out 4, sorry. So we got 2 plus 18 plus 18. 126. Okay, sorry, my MR was wrong just now. Okay, now we can just continue from here. So 0.75 multiplied by 126. The mass of the salt that we need will be 94.5 grams. There you go. So I wanted to make sure that my calculation for MR is correct. If my calculation for MR is wrong, then my final answer will also be wrong. So that's why I have to be very careful and double check answers like I did. Okay, next C. Munira wants to prepare 500 cm³ of a standard solution of hydrated oxalic acid. So she want to make a 0.5 mole of stock solution from the previous one that we had. The previous one meaning here, this one that we created. So name the method to prepare the standard solution. So we are trying to make this concentration to this one, right? From 1.5 to 0.5. So therefore, we're trying to dilute the solution. So it's called dilution method. Okay, you get 1 mark from here. Calculate the volume of stock solution needed to prepare the standard solution. So now we need to calculate and see from 0.5 mole per dm³, how much do we need to add inside the new, how much should we put from the 1.5 mole per dm³ into 0.5 mole per dm³. So meaning to say right now, what we have, I'm just going to illustrate to you how it looks like. So what we have is a standard solution. Here we got 1.5 mole per dm cube. Okay, we are talking about how much do we have to transfer into a new beaker, okay, to make it 0.5 mole per decimeter cube. That's the idea. So we can always just use the M1 V1 and M2 V2, because in the end, after that, we're going to get 500 as well. Okay, another stock solution of 500 cm cube. So if we use the formula of M1 V1 is equals to M2 V2, we're going to make V1 as our subject. So V1 will be M2 V2 divided by M1. So this one is supposed to be your, it's supposed to be your V2, M2, M1. So if we substitute the value in, you'll get 0.5 times 500 divided by 1.5. And the volume you must add inside will technically be 167 cm cube. You get 2 marks. If you get everything correctly, you should be able to score a total of 9 marks for this particular question. Nice. Next, number 7. Diagram 7 shows how process Z convert natural rubber into vulcanized rubber. So based on the diagram, name process Z. So when you want to create vulcanized rubber, you must undergo vulcanization. Okay. So it's a very easy process. So just put here vulcanization. Okay, so explain how vulcanized rubber is produced. 1 mark. So it's very easy. You can say that we can actually immerse natural rubber into sulfur dichloride solution. So you say here immerse natural rubber into sulfur dichloride solution. Here 1 mark. All right, which rubber is more elastic? Explain your answer. So usually vulcanized rubber is more elastic. And the reason why is because there is a cross linkage between the rubber molecules, okay? So it can provide the polymer chains from sliding away or stretch. So you put here vulcanized rubber, they give you 1 mark already. Because the presence of cross linkages between the rubber molecule strengthens the structure. Okay, and after you can just say that when they are stretched, it prevents sliding. It prevents the layers from sliding. So that should give you 3 marks in total. Okay. So that would be the answer to explain why vulcanized rubber is actually much more elastic compared to the unvulcanized rubber or natural rubber. Right? Uncontrolled usage of synthetic rubber leads to environmental pollution. Suggest 2 ways to overcome the problems resulting from the widespread of the usage of synthetic rubber. So it's asking you that it's telling you that when you use all these synthetic polymers, they actually result in a lot of waste being generated, and that could actually cause pollution, right? So how can we fix these problems? Usually it's about make sure that you don't simply discard the rubber materials. So one of the things that we can do is actually to reuse the rubber for other purposes. So you can put here, say, reuse synthetic rubber for other purposes. Like, for example, such as tires, car tires and synthetic rubber. So car tires can be reused as a flower pot, for example, you can plant things inside. Car tires can also be made to swing, can be used as a float. A lot of users, like if you're creative enough, I think anything at all can be reused into different purposes, right? Even plastic bottles can be used into hydroponic systems, or perhaps can be used to make pencil cases. Like I said, the limitation is only based on your imagination. So if you're the more creative you are, the more likely you'll be able to find a use for it. And another one will be, you can also say that to ensure that the synthetic rubber is disposed properly, right? Have law enforcement, for example. So you can say here, law enforcement to ensure that the disposal of synthetic rubber is properly done. So that's 2 marks as well. Okay, so what are the advantages of gloves made from synthetic rubber as compared to natural rubber? I think you can just list down very simple ones. Like, for example, the first one will be oil or grease resistance. Oil or grease resistant. And then we have, I think it's more durable or more elastic. I can put durable, you can put that more elastic. Okay. You can also say that it is actually heat resistant. And also chemical resistant. Okay. I mean, any of one of these answers can be used as an answer. As long as you get it correct, you should be able to score 3 marks. And then total for this question will be 10 marks. Okay, let's take a look at the next one. Question number 8. Azro and friends carried out an experiment to investigate the factor affecting the rate of reaction between powdered metal zinc and hydrochloric acid. Table A shows the information about the reactants and the time taken to collect 30 cm³ of gas. So one, you can see that we use a lower volume of acid and 1 mole per dm³ hydrochloric acid, and the other one we are using the same thing, but we're changing it to higher volume and lower concentration of hydrochloric acid. So one is 10 and one is 20. So what is the meaning of rate of reaction? So rate of reaction is the measure of how fast or how slow the reaction is. So I think what you can write over here is okay, but this says based on the reaction. So rate of reaction based on this experiment will be the change in the volume of hydrogen gas per unit time. Because this is not an operational definition. If you see properly, right, it's actually referring to rate of reaction, but it didn't say based on the experiment, so it can be a general answer also. So general answer here will be a change in the amount of reactants or product, okay, per unit of time. So you get 1 mark for this. So this is a general definition lah. If they ask you for operational definition, then it must be exactly from the question itself. For operational definition, you can say that the time taken for the amount of hydrogen gas to be collected over time. That gives me an answer. So gas for B, state the gas produced. So the gas that is produced over here will be hydrogen gas. The reason why is because when you react zinc with hydrochloric acid, you will get zinc chloride salt and you will get hydrogen gas being produced. So this one tells you that H2 gas is the answer. So as you write an ionic equation for this reaction. So for ionic equation, you have to write the 2-half equation to be easier, okay? So 2-half equation over here will be zinc itself produces zinc ions and it releases 2 electrons. And then what happens next is will be that the hydrogen ion will accept the electron and undergoes a reduction process to produce hydrogen gas. So to write the overall ionic equation, you just have to cut and then write whatever is before the arrow together. That's the easiest way. And then put whatever that's after the arrow together. Then you'll be able to write the correct answers. That's it. So therefore, that's the answer. For C1, calculate the average rate of reaction for experiment 1 and 2. So average rate of reaction will be total gas collected over total time. I'm going to divide into 2. So the first one is for experiment 1. So the first one will be rate of experiment 1. So the rate for experiment 1 will be 30 cm cube of gas collected. So 30 cm cube of gas over 10 seconds. So that'll be 3 cm cube per second. That's the first one. And then the second one will be rate of experiment 2. So that will be 20 seconds. So 30 cm cube divided by 20 seconds. So that will be 1.5 cm cube per second. That's it. So you calculate correctly, you get 2 marks. Based on your answer, compare the rate of reaction between 1 and 2, state the factor that affects the rate of reaction. So in this case here will be concentration. Okay, so you see over here that experiment 1 has a higher rate compared to 2. Okay, then after that, you can just say that the factor that affects rate is concentration of acid. There you go, done. Okay, so 2 marks in total over there. So that is the answer. And then for the third one over here, by using collision theory, explain the difference in the rate of reaction for C2. So you just put here that in terms of collision theory, you must answer like how does concentration affect law? So you say that a higher concentration results in more reactant particles, then it results in more collisions between the particles, which will then increase the number of effective collisions, which then will allow more more products to be formed in a shorter period of time. So you say here, a higher concentration of hydrochloric acid contains more hydrogen ions. Okay, so that's the first part. And after you just say that the frequency of collision between the hydrogen ions and zinc is higher. Sorry, is higher. Okay, then you can say here this results in higher effective collisions. Higher number of effective collisions. Then you should be able to get 3 marks already. So there's 3 points being mentioned over here. So once you get all 3 points correct, you should be able to get 3 marks in total. So then that's pretty much for this question. If you score all correct, you should get 10 marks out of 10 marks. All right, so let's go to section B. This is question number 9. Substances X and Y are 2 colorless substances, which is in the liquid state. Diagram 9.1 shows the setup apparatus to determine whether substances X and Y are electrolytes. So in this case here, we have carbon electrodes, and what you can notice is that they have 2 different substances, which is X and Y. And if we see the what's it called? The diagram, you will notice there's actually a light bulb over here. It's a light bulb over here. But the light bulb, which is on the left side for substance X, it actually lights up. But substance Y does not conduct electricity. So what happens here is that the light bulb is technically not lighting up. Okay, so which means there is electricity being produced, or the circuit is complete on the left side, but not on the right side, which tells you that technically substance X is actually technically an electrolyte, but substance Y is not an electrolyte. So state the meaning of electrolyte. So electrolyte is a chemical substance that can conduct electricity. So normally it has technically has ions in a way. So we can consider that as an electrolyte lah. All right, or any other way of defining what electrolyte is. But usually when we talk about electrolyte, we can just say that it is a substance that can conduct electricity, either in a molten state or an aqueous solution, and it undergoes chemical changes. So for this particular part, I'm going to use, you can just say here, electrolyte is a chemical substance that can conduct electricity in a molten state or aqueous solution. So that's the answer lah, technically. Okay. So they give you one mark. Which substance X or Y is an electrolyte? So I think I explained to you earlier that X is supposed to be electrolyte. So the reason why is because it is able to light up the light bulb. Okay, and also I can say that supposedly it can conduct electricity. So you put that X because it is an aqueous solution that contains ions to carry electrical charges. So there'll be 2 marks. 1 mark for stating which substance, and the other one will get another one mark for the explanation itself. Okay, let's go to B. Diagram 9.2 shows the apparatus set up for a chemical cell A. All right, and it says here magnesium electrode is used on the left and the copper electrode is used on the right. So this is actually a Daniel cell. You can see that there's a salt bridge over here. All right, so this is called the salt bridge, and the salt bridge technically connects both sides to allow the movement of ions so they can actually conduct electricity to complete the circuit. So on left side got magnesium electrode, right side got copper electrode. On the left side, you have the magnesium nitrate solution with a concentration of 1 mole per decimeter cube. And on the right side, you have the copper 2 nitrate, which is also 1 mole per decimeter cube of concentration. So based on diagram 9.2, number 1 here says write the cell notation of the chemical cell. So the cell notation is actually very simple. The cell notation of a cell is written as Mg. You must put the state of matter. So magnesium is a solid, followed by a boundary in equilibrium with its ions. So the ions are actually in the aqueous form and with a concentration of 1 mole per dm cube. Okay, and after that, supposed to be a salt bridge in between that. And then there should be a continuation from there, where you will now write the copper part. So copper ions first. Again, it is an aqueous solution with also a 1 mole per decimeter cube of concentration, followed by the copper in a solid form. So that's all you have to write to get full marks for the cell notation part. Okay. State the observation and write a half equation at the magnesium electrode. So what happens here is that the magnesium electrode actually dissolves or becomes thinner over time. So let's take a look at the observation first. So the observation, you can just put here, magnesium electrode dissolves or becomes thinner, up to you. And the half equation here will be magnesium being oxidized to magnesium ion, and it releases 2 electrons. So that's the answer lah. Okay. If you get both correct, then you get 2 marks for this particular question. For number 3, if the magnesium electrode and magnesium nitrate solution in chemical cell A are replaced by iron electrode and iron 2 chloride solution from chemical cell B, explain the difference in cell voltages of the chemical cells between A and B. So if you were to replace the magnesium with iron electrode, okay, and then you try to measure the cell voltage of both the cells, what will happen? So you have to use this way to calculate. You're supposed to calculate the voltage produced. So I think we'll need to calculate for the first cell, which is between magnesium and copper first. So if we're gonna measure the voltage between magnesium and copper first, the E naught of the cell is equivalent to E naught of the positive terminal minus the E naught of the negative terminal. So the negative terminal is the one that has a more negative E naught value. So in this case here, it will be magnesium that is negative terminal, and then copper will be the positive terminal. Okay, so we'll start with the positive terminal, which means that the voltage produced for the cell is between magnesium and copper will be positive 0.34 volts minus negative 2.38 volts. So that would technically be 0.34 volt plus 2.38 lah. So if you were to write this correctly, you should be able to get 2.72 volts. All right, so that's the first answer. Then you write this correctly, you should be able to get 2 marks already. And then between the other one, which is copper and iron, right? Because I asked you for copper and iron as well. So between copper and iron, same thing, lor. E naught of the cell will be E naught of the positive terminal minus the E naught of the negative terminal. So I would say in this case right now, we'll take the copper again, because copper is more positive. So 0.34 volt minus negative 0.44 volts. And you're supposed to be 0.34 plus 0.44 volts. And your answer is supposed to be 0.78 lah. Okay, 0.78 volts is being produced. So that's the second part of the answer. So they're supposed to then, after calculating it, right, you're supposed to explain the differences between the two, okay? So what you're going to explain here is very simple. You can say that the voltage, the E naught cell okay, E naught of this, okay, never mind. It's quite hard to write, but okay. E naught cell of magnesium and copper is greater than the E naught cell of copper and iron. Okay, that'll give you 1 mark. And after that, you can say that the greater the difference in the value of standard electropotential pairs of metals, the greater the voltage reading. So that's the last mark they can get lah. Okay. So you say here, the greater the difference in the standard electropotential values between the metal pairs, the greater the voltage produced. So when you explain all this, like for example, 1, 2, 3, and 4, then only you'll be able to score a total of 4 marks lah. Okay, so that's how the marks are actually distributed. I know the space is not enough. Usually they'll give you another separate answer sheet, so you have to use that answer sheet to answer questions lah. But in this case, we'll just use this explanation over here. You can always take a piece of paper and try to write the answers down. I think that'll be much neater and much better in terms of an answer. Okay, let's go on to C. Diagram 9.3 shows the apparatus setup used in an experiment to study the electrolysis of copper 2 chloride solution. So we have the first one, which is a electrode P and Q, which are carbon electrodes. And the solution used over here will be 1.0 mole per dm cube of copper 2 chloride solution. We regard this as a concentrated solution, yeah. So anything that is 1 and above, 1.0 mole per dm cube and above, we will consider that as a concentrated solution. Okay. And then this one will be very diluted, as you can see with there. Same carbon electrodes are used, but the copper 2 chloride solution is actually 0.0001 mole. So this is considered as a diluted solution. Okay. So after that, what happens is that the switch is closed and left for 20 minutes. Table 9 shows the observations after 20 minutes. So the first experiment, what you can see is that there is a greenish yellow gas being produced at the carbon electrode P, and then the brown solid is formed at the carbon electrode Q. Intensity of the blue coloration decreases. And then for number 2, colorless gas is produced, carbon electrode R, brown solid is formed at S, and intensity of the blue color solution decreases also. So these are the product of electrolysis, okay, at carbon electrode P, Q, R, as well as S. So it states here, state the name of the products, the electrode P, Q, R, and S, explain the observations, and write half equations at the anode and cathode of experiment 1. And they actually give you the E0 values, okay, the E0 values of the different substances over there. So let's tear down the question and see what they want. So they actually want you to explain what are the products being formed at P, Q, R, and S. So perhaps I can actually list it down for you already. So I'm going to create an extra page over here so that we can explain to you what is going on. Okay, so P will be definitely chlorine gas, because why? We saw there's a greenish yellow gas being produced, okay? So electrode P, chlorine gas is produced. All right, and then Q will be copper metal because it is brown. R should be oxygen gas because it's colorless. And then S will be copper as well, which is also brown. All right, so chlorine gas, copper metal, oxygen, and copper metal. All right, and then what I can say here is that they will probably ask you what's going on at P, because they are referring to extra questions here. As you can see that they're actually asking you, right? State the name of the products already, you should get 4 marks over here. But they say explain the observation that is occurring at experiment 1, right? Explain the observations that's happening in the anode and cathode of only experiment 1. So not comparing 1 and 2, we're just technically comparing in terms of 1. Okay, so keep that in mind. So in this case over here, why do we say that in this case for the first experiment, so this is the experiment 1, it's asking you to explain in experiment 1 why chlorine gas is being produced. So you can explain that at P, Cl2 gas is produced, or you can also say discharged, because Cl minus has a less positive sorry. Concentration base is not about E0 value. So you say discharge because concentration of Cl minus is greater than OH minus. That'll give you 1 mark. All right. And after that, you can talk about the copper at Q. So at Q, Cu metal is produced
because the E naught value of copper is more positive or less negative, up to you, compared to E naught value of hydrogen. So that should explain of that, okay? Do keep in mind that we're talking about E naught value of Cu2 plus, yeah? And also this is regarding H plus ion. So that's the answer. So if you answer all correctly over here, you should be able to get like 4 marks in total. Then if you get this correct, you get 1 mark. This is correct, you get 1 mark. And then they also ask you to actually write down the half equations, you see, for the anode and cathode. So I think that's pretty easy as well. So the half equation at the P or the anode will be Cl minus first. So it's 2Cl minus becoming Cl2, and it releases 2 electrons. And then the half equation at the cathode will be 1 Cu2 plus 2E, you get Cu. So if you get both half equations correctly, you should be able to get 2 marks in total. So that is basically all for this particular question, okay? So I think it's pretty easy, to be honest. All right, so let's go to the next part. So next part for D, diagram 9.4 shows a conversation between Ahmad and Mei Ling. So it says here, Mei Ling, I would like to coat my iron ring with layer of silver. Can you show me how to do it? And Mei Ling says, yes, Ahmad, I will show you the apparatus setup. So draw a label diagram for the Ahmad's activity. So again, Ahmad actually wants to electrolyze a ring, an iron ring actually, with a layer of silver. So I think the diagram should be very simple in this case. So what you can draw here will be, you need a battery, of course. So very simple sketch, so don't have to draw it very nice, like it's 2 marks only, but make sure you label everything that's important. So I'm going to put the silver on the left and then the ring on the right. So draw a very simple ring will do, okay? If you want to draw it nicely, also can. If you want to draw something like this, something like this. Okay, okay. And then after that, of course, you have a beaker. And then after that, you have another beaker over here. Make sure that the ring is completely immersed inside the beaker. You have a switch if you want to. So that's pretty much about it. And of course, label everything. So this will be silver electrode. This will be your iron ring. Remember the material used for plating must be the anodes, and the object to be electroplated must be the cathode. And then the electrolyte must be something that contains the plating material. So in this case, we're going to use silver nitrate solution because it is the soluble one. Never use silver chloride because silver chloride is insoluble. So silver nitrate solution will be the best. So I think that's pretty much about it. Just label all this easier for you to see. And then once you draw everything correctly, you should be able to score 2 marks in total for this question. All right, okay, so let's go to number 10 right now. Number 10, shows the apparatus setup to compare the heat of displacement of copper from copper 2 sulfate solution by magnesium powder and zinc powder. Right. So basically what happens here is that you're going to perform a displacement reaction between zinc and also magnesium, right, in copper itself. So magnesium and zinc here being a more reactive being a more reactive metal and a more electropositive metal, you'll be able to displace copper out from its own salt. So over here, what you can see is that the initial temperature for both sides will be 27 degrees Celsius. And then after that, there's an increment of temperature. So I will say that the temperature increase for set 1 will be about 5 degrees Celsius. And for set 2, it will be around 4 degrees Celsius. So by choosing either set 1 or set 2, answer the following question. State the meaning of heat displacement, one precautionary step while conducting the experiment. State another observation other than change in temperature. Write the inference for the observation. Okay. So I think let's take a look at what's the definition of a heat displacement. I would say heat change lah. Okay, heat change or heat release. So we'll try to write this very, very small. Heat release when 1 mole of copper ions are displaced with zinc metal. Okay. From its own salt. If you're going to be more specific, you can also say that from copper to nitrate, isn't it? Copper to sulfate, sorry. From copper to sulfate solution. So this is done. One precautionary step, we can say that we can actually cover the polystyrene cup, all right, with a cover or a lid. Or you can also say that stir the mixture using thermometer also can. So I think stirring the mixture will be better because we want to make sure everything reacts evenly, right? So stir the mixture with thermometer. Okay, that'll be the best. You can also mention that we should use polystyrene cup. Also can, because there's also another precautionary step. Use any other materials, the heat might be lost to the surroundings. So that's not what we want. Okay. And then I'll state another observation other than change in temperature. So what we will see is technically the metal will dissolve, right? The metal will dissolve, and also you'll be possibly seeing the brown metal be deposited at the bottom. So any of those can be accepted. So you can either say zinc or magnesium metal dissolves. Or you can say that brown solid is deposited. Because there are two scenarios, two different answers you can use in this question. But they're answering for one only, so 1 mark, so just give them one only, right? And then they ask you for one inference. Inference refers to a reason, all right? A reason of what you see, what kind of observation. So you're seeing that, for example, the brown solid is deposited and the zinc metal is actually dissolving, for example. So what is your inference for this particular experiment? So you can say that the I think zinc reacts with copper 2 sulfate solution, or you can say that the zinc has is more reactive, so it displaces the copper. So any of those inference can be used in this case. So perhaps if I say the metal dissolves, then you can say that the copper, okay, it depends on which one. Okay, if I'm talking about this one, I'm talking about zinc and magnesium, metal dissolves. So you can say it reacts with it. But if you want to talk about the brown solid deposit, you can say that copper is formed. Okay, copper is formed, which is for only this part over here. For zinc and magnesium one, if you want to write something else about it, you can say that magnesium or zinc reacts with copper 2 sulfate solution. So that is an answer you give. Then done already. So if you answer that correctly, you should get 4 marks in total. Okay. All right. Then after that, it says here, calculate the heat of displacement for both sides of experiment. Explain why there's a difference in the value of heat of displacement, given that the heat capacity is 4.2 and then density of water is 1 gram per cm cube. Okay. So it's supposed to calculate the heat of displacement, for 2 sets, for 1 and 2. So what I'm going to do here is going to calculate using 2 formulas. The 2 formulas that you must use will be Q is equivalent to MC theta, and then you're going to use delta H is equivalent to Q over N. So M is actually the mass of the solution, C is the specific heat capacity, theta is the temperature change. So for the first set over here, Q is equivalent to MC theta. The mass of the solution is 100 grams because it's 1 gram per cm cube. So 100 multiplied by 4.2 multiplied by a temperature change we just calculated over here, which is 5. So that would be technically, let me check and see. Give me a calculator, give me a minute. So that will be 100 times 4.2 times 5. That will be 2,100 joules. But before we calculate delta H, we need to change it to kilojoules first. So that will be 2.1 kilojoules. And then after that, we need to calculate number of mole also. So number of moles should be following the number of mole of the copper 2 sulfate. But you have to write the chemical equation first. So in this case, the first one, set number 1, magnesium reacts with copper sulfate to give you magnesium sulfate plus copper. The other side also same thing, zinc plus copper 2 sulfate. And then you get zinc sulfate plus copper. So in terms of number of mole, they are all 1-to-1 ratio, like 1, 1, 1, 1, 1 mole, 1 mole, 1 mole, 1 mole. So all 1-to-1 ratio. So now what we can do is that we can calculate the number of mole of magnesium that displays the copper, isn't it? So the number of mole of calcium ions, copper ions will be based on the concentration of copper 2 sulfate. So N, which is now going to be the number of mole of copper ions, will technically be following these 2 information over here, where we can use MV over 1000 because it is a solution. So the molarity will be 0.5 mole and the volume is 100. So divide by 1000, you'll be able to get 0.05. So number of mole is 0.05. So right now to calculate delta H value for the first set, it will be 2.1 kilojoules divided by 0.005 mole . 2.1 divided by 0.05. So you have 42 kilojoules per mole. Negative, because exothermic reaction must put a negative over that. Then you'll be able to get marks for that. The next one will be same thing. Q is equivalent to MC theta. So for zinc will be the same thing also, 100 times 4.2. But the temperature change is only 4 degrees Celsius, slightly lower. So it'll be 4 over here. So let's see what you get. So you only get 1680 joules, which can then be converted into 1.68 kilojoules. For the N, it is the same because the amount of copper ions are displaced is the same for both sides because we're following the concentration of the copper 2 sulfate solution. So this is also 0.05 mole. Then what we can do is that delta H value will now be 1.68 kilojoules divided by 0.05. And let's see what do we get from there. So that will be around negative 33.6 kilojoules per mole. All right, so that will technically give you that particular answer. So in terms of the heat of displacement, we will say that magnesium and zinc, there's a difference. So magnesium's heat or displacement towards copper will be higher compared to zinc. So that's the comparison that we can make over here. Okay, and then you're supposed to explain the reason why. And why do you think there's a difference in between the heat of displacement? So you can just say that the heat displacement of set 1 is higher than set 2 because magnesium is more electropositive than zinc, all right? Or it has a more negative E0 value. I mean, like, no, we talk about reactivity series, right? Okay, no, we'll just talk about electropositivity. So the final answer here will be heat of displacement of Mg. Okay, never mind. Only Mg is put offset 1 is higher than set 2 because magnesium is more electropositive than zinc. That's it. And then you'll be able to get full marks already after that. So you get 6 marks in total. Done. And this is table 10.1 shows number of carbon atoms and per alcohol molecule and the heat of combustion of methanol, ethanol, propanol, and butanol. So you're supposed to then see the information on the table. And after that, by using data in table 10.2, draw a graph of combustion against the number of carbon atoms per molecule on 19. And from the graph plotted, determine the value of the heat of combustion of propanol. So you notice that we have values for methanol, ethanol, butanol, right, for the heat of combustion. But we don't have the data for propanol. So for propanol, right, you're supposed to draw the graph first and everything, then trace back from the 3rd carbon atom and see where you get using the graph. So how do we get that? You have to look into the graph law. So if you plot the graph already, you'll be able to see something like this. So this is the graph plotted based on the information that we got from the table. So it's actually a straight line across. As you can see over here, once you get the value, there will be slightly of an outlier for 1 point, but it doesn't matter. We're just going to draw a best fit line. So once you draw a best fit line already, right, you will then be able to trace back for propanol, 3 carbon atom, propanol, and you can see the blue line that's drawn. That's how we trace back to the value that of the heat of combustion that can be produced using the graph. So after drawing the blue color line, we can see that the heat of combustion is actually this point over here. And the value that is produced here should be technically around close to 2,100 lah. But it's slightly lower than that. It's supposed to be like 2090. Okay, so 2090 is the value that you're supposed to get. So 2090 kilojoules per mole. So after tracing it back already, you can then go back to the question and then trace back and right answer that. Okay, so that is how we get the answer for propanol. So after looking for the answer, right, you're supposed to not drop off the line, let the blue line remain there so that the examiner can see whether how you get your answer technically. So the answer is supposed to be 2090 kilojoules per mole according to this lah. Okay, but it all depends on how you draw your graph and how you get the answer. So once the examiner sees correct, you're supposed to get the correct marks for that. Okay, all right, let's then move on to the so for the next question, number 2, explain why the heat combustion of propanol and butanol are different. Include chemical equations for the complete combustion of propanol and butanol to aid your explanation. So I think it's very simple to explain why they have different heat of combustion. So in this case here, let's write the complete equation first. So for the propanol's combustion, it should be C3H7OH plus 9/2O2 to get you 3CO2 plus 4H2O. All right. Now, in this case, if you don't want the fraction, you can always write ×2 the whole thing. So with ×2 the whole thing, it'll be something like this. Now, of course, I will always encourage you all to write a whole number instead of writing a fraction, because usually they don't really like it when you write fractions in your chemical equation. So I think this is actually the best one. Okay, so that's the correct version. And then for butanol, it will be C4H9OH, and then you plus 6O2, you will get 4CO2 plus 5H2O. All right, so explain why there are technically higher heat of combustion for the butanol compared to propanol. So you can talk about the number of carbon atoms per molecule. Okay, so you say here the first one, the number of carbon atoms per molecule for butanol is greater than propanol. Okay, then after you can say that more carbon dioxide and water is produced. And more heat is released. So you should be able to get 5 marks after that to explain all these things. So once it's done already, you'll be able to get full marks for the question itself. Okay, let's go to C. 10.3 shows a comparison of heat of combustion of 2 fuels with methane and methanol. So one is alkane and one is alcohol. All right. So then after that, we see here, Yusuf created a machine to help to speed up his work in the workshop. Based on 10.3, choose the most suitable fuel for your machine. Based on either the fuel value or the effects of the fuel on the environment, justify your choice. So let's take a look at the difference between methane and methanol. So what you need to do is that you need to actually calculate the heat release first for both substances. Okay. Or you can also compare in terms of pollution, because when we talk about alkanes and alcohols, right? Alkanes, apparently they can burn and there will be soot being produced. Soot as in the carbon deposit. But for alcohols, they always undergo full combustion or complete combustion. So there will be no pollutants being produced by the alcohol when you burn it. I mean, besides carbon dioxide, of course. So there will be carbon deposits produced by methane, and therefore there'll be smoke in the air. But methanol don't have lah. So I would say that methanol will be a cleaner gas, cleaner fuel to be used compared to the alkanes. That could be one justification, or that could be one of the reasons why you choose methanol compared to the other lah. That is just one choice. But there's no wrong or right in this question. Like it means that it doesn't mean you have to choose methanol over methane. You just have to justify which is which lah, okay, which is better. So let's just say if your choice happens to be methane. Okay, let's just say your choice happens to be methane. So what are the points that you can give to justify why methane is better? So you can say here, methane can produce more heat per molecule. That's one of it lah. Okay. Or you can say here, produces more heat energy per gram, or per gram, because it says here per mole. So you can say per mole, so if you want. Okay, and then after that, you can say that it has a higher fuel value compared to methanol. So that's if you want to use methane as a fuel. Okay. If let's just say you want to use methanol as a fuel and you want to justify why. So for methanol, you can say that it is has a lower percentage of carbon compared to methane. Okay, and after that, you can also say that it produces no soot when it is burned. During combustion. So I would say it's a more environmental friendly kind of fuel. So whichever way you try to justify, I think as long as your answers are logical and rational, you should be able to get marks for it. So I think 2 marks means 2 points will be enough. Then you'll be able to score full. Okay, so that's pretty much about section B. Let's go to the last section, which is section C. And you're supposed to answer the question, all the questions over here. So let's go to number 11. So diagram 11 shows the conversions of compound X and compound Y. Compound W as a molecular formula of C4H10O. So we'll start from there. So I think C4H10O is for W. That's the molecular formula, might I say, right? So then you can see here, I would say most likely this is an alcohol, right? Because the fact that it can undergo oxidation, it can undergo this reaction with porcelain chips. So it's most likely showing you an alcohol. So let me just rewrite this formula for you so you can understand better. So this is supposed to be butanol, which is C4H9OH. Then this makes more sense to you. So once you oxidize butanol, you should be able to get butanoic acid. Okay, butanoic acid. And then if you were to go through with the porcelain chip on the reaction number 2, it should be able to undergo a lot of, okay, we'll go through one by one, but technically the number 2 here will be dehydration. Because if you use porcelain chips, means it's actually dehydration, and then you'll be able to get butene out of it. Right, and then I can see here, reaction number 1 here produces carbon dioxide and water. So most likely this is actually combustion reaction. So we know that alcohols can undergo combustion very well. So now that we've solved the mystery of every single component over there, I think it's easier for you to answer the question lah. So usually I will advise my students to actually solve the mystery first, right? Try to figure out what is what, if you can, in a flow chart. Then when you answer the question, it comes naturally to you. It's like so easy, much more easier compared to cracking it one by one. So based on diagram 11, name the compound W. So we already did that already, the formula. So that's actually butanol. Okay, you can always choose to write butane 1-ol or butane 2-ol, it doesn't matter lah. And then you can see, it says here W can form 2 isomers. So draw the structural isomers and name one of the isomer. Draw any one that you want. I'm going to draw a very simple isomer of butanol. So I'm going to do butane 1-ol because it's much easier. So let's attach the OH at the end over here. The rest of it you just fill up with hydrogen. So we call this as butane 1-ol. So done already. And state the name of reaction number 2 and write the chemical equation. So reaction 2 is called dehydration, which we already wrote this down. So you can see, right, it's actually much more easier right now for you to write answer down once you know what's going on. So that's 1 mark for you. And then the chemical equation will be C4H9OH undergoing dehydration to give you butene, which is C4H8 plus water, H2O. So now that you write everything down correctly and draw the correct picture, you should be able to score 5 marks very easily. So that's pretty much about it. Okay, number 2. Calculate the volume of carbon dioxide gas produced when 7.4 grams of butanol is burned in excess oxygen. So let's just take the equation. So C4H9OH plus oxygen, you get 4CO2 plus 5H2O. So supposedly you will get a fraction. Oh no, you won't actually. Okay, so you got 5 oxygen on the right side plus the carbon dioxide here. So you got 8 oxygen. Here got actually 5. So it's supposed to be 13 minus 1, so it's 12, so this is 6. Okay, now it's balanced. So for every 1 mole of butanol, you get 4 moles of carbon dioxide. So it's a 1:4 ratio lah. So let's just say right now, want to find out what is the number of mole, the actual number of mole of ethanol. So number of mole will be, so you got 7.4 grams that's indicated over here, but you have to find out what is the MR of butanol first. So the MR of butanol is, let's see, 4 times 12 will be 48. So it'll be 48 plus 10 plus 16. 10 because here got 9 hydrogen, here got 1. So you have a total of 10 hydrogen, and then you got 1 oxygen. So 48 plus 10 plus 16, the total is 74. So 7.4 grams divided by its relative molecular mass, which is 74, you should be able to get 0.1 mole. Okay. And then after that, you got 0.1 mole for the alcohol. Here should be times 4. So it'll be 0.4 mole. Because it's 1:4 ratio means it's 0.1 to 0.4. That's how we compare the ratio, right? So it's 1, for every 1 mole, you get 4 moles. So every 0.1 mole, you should get 0.4 mole of carbon dioxide. And assuming that everything is measured at room conditions, the volume of CO2 will be 0.1 mole multiply by 24, which will give you 2.4 decimeter cube. All right, double check and see if the question wants you to put it in a specific unit or not. Meaning to say, sometimes they will ask you to include maybe the answer in cm cube or in dm cube. So it's better for you to check, double check and see lah. So I'll say over here, since it didn't say anything, you can just leave it at decimeter cube, it's fine. So you get 2 marks for the calculations. B, a student was given 2 colorless liquids, which are alkane and alkene compound. Her teacher asked him to do a confirmation test. It's a bit confusing. So it says here, her teacher asked him to do. What? Okay, never mind, it's okay. It's supposed to be either him or her, but it seems like it's 2 now. You get what I mean? State and describe a chemical test that can be used to distinguish the 2 liquids. So if you want to differentiate between an alkane and alkene in this case, we actually perform something called the bromine water test. Okay, so what we do is that we can actually add a few drops of bromine water inside the solution, inside both of the solution, not solution, sorry, both the liquids, and then shake it, and then see if there's any discoloration or not. So after discoloration, if there is any kind of discoloration, then you should be able to see that if the alkene is present, it will undergo something called halogenation. And then after that, you'll be able to change from brown to colorless. So the one that contains alkene, if you perform the bromine test, it will turn the liquid from brown to colorless. The alkanes being saturated will not be able to react with bromine. So therefore, the brown color of bromine remains the same because bromine did not react with anything technically. So what you can do here is you can just explain that bromine water test can be used. And after you say here, add a few drops of bromine water into 2 separate test tubes containing alkane and alkene respectively. Okay, then after that, you can say shake the solution well. Sorry, shake the mixture well. Then after that, the test tube that decolorizes is the alkene sample. Then you explain that the test tube that did not decolorize contains alkene. Sorry, alkane. There you go. Okay, so this is just to explain to you how it works. 5 marks, so 5 different points that I put there. Okay, so you say describe the answer. So I think it's the easiest one. There is an alternative, there is also actually an alternative test they can use, which you can use an oxidizing agent, because technically speaking, alkenes can also be oxidized into diols. But I think that's more complicated and there's more things to write. So if you want to differentiate between alkane and alkenes, I think the easiest one to do is actually to just put in bromine water, shake it, and immediately you'll be able to see a result, right? The alkane will not be able to react with the bromine, but the alkenes can undergo halogenation with bromine to produce a haloalkane. So that's the easiest one that we can see. in terms of chemical reaction. So of course, in SPM, we'll try our very best to just give the simplest form of answer to get maximum number of marks, right? So this is it. 5 marks is a lot, but write only a few different points to get 5 marks already, compared to writing an alternative answer, which technically carries more work but lesser marks to get. So might as well just write the easier one, isn't it? So that's for B. You can score 5 marks for that. And then the last one will be Diana wants to bake a pineapple tart. She went to bakery to buy pineapple essence. As a chemistry student, how would you help her to prepare the pineapple essence, ethyl butanoate, in the laboratory by naming 2 substances involved and write the chemical equation for the reaction and the procedure for preparation. So this is more of a experimental design. And if you see closely, they are actually asking you to explain how can we actually prepare an ester of ethyl butanoate, which can give you the pineapple flavor. So you're supposed to describe an experiment. Last, not enough space over here. I'm just going to jump right into the marking scheme to explain to you how the experiment works, and it's much easier that way. All right, so as you can see in the marking scheme, what happens here is that they use ethanol and butanoic acid as the main ingredients, because after all, you're supposed to get ethyl butanoate, right? So as you all can tell, ethyl butanoate word comes from 2 different sections. So for esters naming system, the first name comes from the alcohol, and the second name comes from the carboxylic acid. So that's how we are able to tell that the first one should be ethanol, because ethyl means 2 carbon and it's basically 2 carbon alcohol. So you're supposed to get ethanol. And after that, for the butanoate part, which is a 4 carbon atom part of a carboxylic acid, so it's definitely butanoic acid lah. So that's how we tell that we can actually need to use these 2 different substances. So the procedure wise, you have to explain one part at a time now, okay, how we're going to make it in a very small scale. So the first thing to do is that you need to actually measure a certain volume of butanoic acid. So you say here, measure and pour a variable amount. So I think a logical one will be around 5 cm cube of butanoic acid and put it into a boiling tube, because later you need to boil. You cannot put test tube because later you're going to boil, and you know that you cannot boil test tube will crack. So be very mindful of the apparatus that you use for your experimental design questions, okay? So in this case, I'm going to emphasize here, use boiling tube, because only boiling tube can withstand heat. All right, after you add a few, you measure and you also add around a 5 cm cube, the same amount of ethanol into the same boiling tube. And then after that, you need a catalyst. In this case, it's actually concentrated sulfuric acid into the mixture. And then after that, you heat up the mixture, either using a water bath or a Bunsen burner, doesn't matter. And after that, you heat it already. Then after a while, you're supposed to get the ester. How you know is that there's no color change. What you can do is that you can actually smell it slightly from the test tube's mouth. The fragrance of the pineapple essence will technically come out. So there's a fragrance there, it smells a bit like pineapple. That's when you know you have successfully created the ethyl butanoate ester. Okay, then the last one, we just record the observation form. And since the last question here asks you to provide them with a chemical equation, so the balanced chemical equation that you see over here will be this one. All right, and if you write it correctly, make sure you include the water, because this is a condensation reaction. So water there must be present in your equation, not just write the formula of the ester. So once you're done with it already, then you should be able to score 2 marks just for the chemical equation. So it's actually quite an easy 8 marks question. No drawing is required. If you're wondering, should you include drawing or not? The answer is no need. You don't have to include a drawing, because drawing don't give you marks actually. But the question is, can you actually include a drawing inside? If you want to, will they penalize your mark? Obviously, they will not penalize you. Yes, you are allowed to draw if you want to. Say, for example, you are a very talented when it comes to drawing pictures. So go ahead, by all means, you can try to draw a very nice picture. But never use the picture as a way to describe the experiment. Meaning to say, you cannot just draw a picture all right, of a diagram, and then write down just one word as a procedure. Like, can I just draw the picture and say the apparatus is set up as above? No, you cannot. Then they will penalize you. You won't get marks for that. For the procedure, you must be as precise and as detailed as possible. So you have to write step by step. Even if you draw the picture or label diagram, you still have to list down each and every step that you do, which means you have to start from measuring the components to putting it into apparatus, and then you go on from there. You have to write everything from top to toe. You cannot skip any parts. That is something they must keep in mind, or else you won't get marks for that particular question. All right, so that's pretty much about this particular paper. I hope you guys have already learned something from here, or at least managed to do some revision for your upcoming tests. So I think that's all from me today. I'll see you guys in the next video.